All right. Good morning, ladies and gentlemen. Welcome to SIEW 2020. And today we will have, I think starting from today, we will have the Thinktank roundtables, which is a regular event that's organized by SIEW. And we're really honored to have SIEW invited us to host this roundtable. So my name is Victor Nian, and I'm from the Energy Studies Institute. I'm a senior fellow with the Energy Economics Division. And just to introduce to you our institute, we are actually independent policy think tank that's established under the National University of Singapore, funded by government ministries. And a lot of our work, although you don't see in the public domain, we work closely with government ministries and Ministry of Trade and Industry, Environment Ministry, and Foreign Affairs Ministry on a wide range of energy issues, particularly on carbon capture and storage, or CCS. Today, we're really happy to present to you a panel of experts from a diverse range of expertise that will share with us their experience in the CCS landscape. So today with me, we have Dr. Christopher Consoli, who is a senior consultant with the GCCSI, and he has extensive experience in leading multidisciplinary teams in assess CO2 storage prospects and worked on the full breadth of storage assessment from site evaluation to multinational initiatives. So today, he will also be one of the speakers, the first speaker, giving a speech on current developments in CO2, global CO2 storage. And the next speaker today would be Dr. Muhammad Rajma Sule. So Prof. Sule is from the Faculty of Mining and Petroleum Engineering Institute Technology, Bandung, Indonesia. He is also the center manager of National Center of Excellence on Carbon Capture Utilization and Storage. One of his main tasks, and he will actually speak to us about this project, is to prepare the Windy Enhanced Oil Recovery pilot project. Once launched, it will be the first implemented CCUS pilot project in South and Southeast Asia region. And then we will have Dr. Rustam Binjuni, who is a professor in the Department of Petroleum Engineering, School of Chemical and Energy Engineering, Faculty of Engineering, with University of Technology Malaysia, just across the causeway. He is also the head of Reservoir Management Research Group and a full fellow member of Institute for Oil and Gas, the University of Technology Malaysia. His main areas of research include enhanced oil recovery, CO2 sequestration, rock fluid interactions, nanofluid, and drill cutting waste treatment. And Prof. Rustam will be sharing with us Malaysia's experience in cultivating the opportunity of carbon capture and storage. And then our final speaker for today will be Dr. Ganesh Dasari, who is currently a senior technical advisor in the ExxonMobil upstream research company in Houston, Texas. He has led quite a number of research projects, including reservoir geomechanics, geologic storage dynamics, and conventional shale and oil gases. For the past few years, Ganesh is leading ExxonMobil research effort in CO2 sequestration and transportation. And he's actively working with University of Texas, Austin, Massachusetts Institute of Technologies, Stanford University, and proudly speaking, National University of Singapore with our team to develop the next generation CO2 sequestration technologies. And today he'll be speaking from the industry perspective on carbon capture storage for decarbonization. And then we will have two additional panelists. As you see from our panel speakers, most of us are coming from a technical background, although we will touch on the policy aspect. We do have very interesting angles from the legal, regulatory, and policy. So then we have a panel member, which is me, Mr. Ian Havercroft, who is a senior consultant on legal and regulatory side of the Institute's really interesting work from the global GCCSI. And Ian is leading the Institute on legal and regulatory matters, including delivery of technical reports and analysis focusing on CCS, the future energy technologies and climate change scenarios. And Ian has extensive experience in working on CCS legal and regulatory matters, and he has acted as an expert reviewer and advisor to several organizations, including the IEA and the IEA GHG. And last but not least, we have Dr. Adam Musadi, who is the Energy Center advisor. So Adam is advisor to the Singapore Energy Center and energy centers in general. He's progressing a portfolio of research and R&D effort focused on low carbon energy and products as ExxonMobil's participation in the Singapore Energy Center. So prior to his moving to Singapore as an advisor to the Singapore Energy Center. He has served in a variety of R&D roles in ExxonMobil research and engineering company R&D organizations in New Jersey. He's also coming from the data analytics. He's coming from the complex system science sections and data analytics, and he's been working on problems in reservoir modeling and seismic processing. So Mr. Ian and Dr. Adam will not be speaking today, but he will join the panel afterwards. So just to give you a brief idea of what is going to happen today. So first of all, we'll have 4 speakers presenting on each of the very interesting topics for today. And then we will have the panel discussion at about 11 o'clock. Just before we start, allow me to say a few words that this panel actually comes from the spirit of a project that is funded through the Singapore Energy Center by ExxonMobil on carbon capture, on CO2 storage options, regional CO2 storage options, where we're exploring the geological engineering. We look at the CO2 storage capacity in the region, and then we look at the different options of CO2 transport across the region. And then for our part, the Energy Studies Institute part, we're looking at policy, legal and regulatory frameworks, and how those may play a role to encourage or facilitate regional CO2 storage options to be developed or cultivated so that the region can collectively achieve its decarbonization target in the long term. And just also a few more words about the Singapore Energy Center. Singapore Energy Center was established in 2018, 2019, and is a national center. It's led by ExxonMobil, but it's a national energy center where we're encouraging members to participate and join as an industry-led research R&D center on a variety of topics. And of course, ESI is also a partner, and we are working very actively, especially from the perspective of this CCS project, on the policy, legal, and regulatory issues, on low carbon technology in general, and more generally speaking, energy transitions. Right. So without further ado, I think we will start with today's proceedings. So first of all, please allow me to introduce one more time Dr. Christopher Consoli, or Chris. So please, Chris, floor is yours.
Thank you very much. Thank you to the Energy Studies Institute for having me today and present on the global storage potential around the world and current developments. I'm very humbled to be here with this esteemed panel, so I hope we get a lot out of today's presentations. Firstly, I'll go into the next slide, please. First, a plug for the Global Institute. It's our 10-year anniversary. Over that time, we have developed a consultancy arm, which is the group that myself and Ian are part of. But we're also an international think tank where we join panels and groups much like this to understand the intricate details of CCS at a global perspective. And our mission is to accelerate the deployment of CCS globally. And just a final note that we're a member-based organization. We're owned by our members, and they are from a wide range of governments, multinational energy companies, and technology providers. Next slide, please. So firstly, let's take a snapshot of CCS around the world. This map shows all the locations of CCS projects around the world, both large and small. The primary takeaway here is looking at those larger red, blue, and gray dots. They represent large scale, so over 400,000 tons per annum, capturing, transporting, and injecting CO2 around the world, and they're all commercial projects. CCS is a commercial endeavor, and it's globally distributed. Next slide, please. CCS project pipeline is growing. It's got a long way to go, and I'll touch on that in the next few slides. So what we've, over the 10 years of monitoring CCS projects, we've kept this graph. It shows a pipeline of growth or decline in CCS projects. In 2010, we saw the full impacts of the enthusiasm around carbon capture and storage and the climate change scene generally. But of course, the global financial crisis put a halt to that. And from around 2010 down to the low of 2016, that the flow-on effects of the global financial crisis can be well seen in this graph. But 2017 seemed to be the low, and now the pipeline is rapidly recovering. We're almost at the levels of 2010, but we now have more operational projects, and you can see that in the light blue down the bottom in that graph. So there's more operational projects coming online. That's more technical expertise, each one capturing, transporting, and storing CO2. In December, we'll release our 2020 global status of CCS, which I know many in this room look forward to each year. And I just have to say, watch this space, because you'll be surprised. We certainly were when we put together all the projects coming online. Next slide, please. The flow-on effects of those operating projects are best shown in this graph as well. Today, we're injecting over 200 million tons per annum. And I guess the main thing I want to highlight from this graph is those growing green bars. As it says, they're dedicated geological storage. This represents the emergence of CCS as a dedicated climate mitigation tool. In the past, those blue bars represent CO2 enhanced oil recovery projects. Now, these projects were still critical for CCS as a technology climate mitigation tool because it provided CCS a commercial return for injecting the CO2. And as well, it gave us the ability for the CCS industry today to say, hey, we can do this at scale, the scale required. Next slide, please. And this is the scale required. Unfortunately, the number of projects that I've just showed you and the storage rates are nowhere near enough the required deployment rate for carbon capture and storage under any climate scenario that we find. Here's an example from the IPCC's 1.5 degree report. And we were astonished when this report came out and how much CCS deployment is required. We need to inject somewhere between 350 gigatons per annum and 1,200 gigatons per annum between now and the end of the century. And as you saw in those graphs, we're still at the million-ton scale. So between, according to the IPCC 1.5 degree report, that is keeping the climate below 1.5 degrees, we need to, between now and 2050, we really need to start decarbonizing the industry. And in between now and 2040, it's really around retrofitting power stations, modifying steel and cement industries, chemical production, as well as the natural gas and oil refining industries. But also hydrogen will play a major part in this 350 to 1,200 gigatons. Post 2040, 2050 and out to 2100, the main role for CCS will be the removal of carbon dioxide from the atmosphere, known as, the technologies are known as Bioenergy Ccs or BECCS and direct air capture or DACs. And what we are seeing increasingly as we use up our carbon budget, that the role of negative emissions or carbon dioxide removal increases dramatically. The challenge is huge. Getting to 350 gigatons to 1,200 gigatons per annum is massive. In some days it's overwhelming, but it's also a massive opportunity. Now, to put it in context, around 2050, if CCS is to be deployed at the scale required, according to climate change mitigation scenarios, it will be around the same size as the current gas industry, and in some cases, much larger. That's an incredible rollout rate between now and 2015, but a really exciting opportunity. Next slide, please. So the next couple of slides is really focused on the geology. I'm a geologist, and so that's probably the best place that I can talk to this audience today. And I'm really going to emphasize if we can meet that challenge. The first question I get asked is there enough geological storage available to store the scenarios required? This slide shows a map that we created and published in our last status report. And it shows the theoretical resources around the world for storing CO2 in gigatons from people and researchers and industry that have mapped the geology around the world. What we can say quite happily is that under conservative estimates even, the global storage capacity is several times larger than the required scenarios for CCS. But I'll highlight the United States. The United States undoubtedly has probably the best, or undoubtedly has the best understanding of their storage resources. They've been continuously studying their CO2 storage potential and actually drilling to identify those storage resources across the United States. And the 2015 Atlas confirmed somewhere between 2,000 and 21,000 gigatons of CO2 available for carbon capture and storage. And what we are starting to see as more countries mature their storage prospects, this pattern is being globally repeated. It's important to emphasize that this is only the theoretical storage potential. Today, we can happily say that there is conservative estimates to meet the targets. The next step globally needs to be characterizing that geological storage locations, understanding where those good sites are and where there's not enough good sites for a country to meet their targets, and that will happen. Next slide, please. So this slide is the second challenge that I often get asked. Can we meet those targets? Do we have the technology, the experience, the tools available to meet a gigaton per annum storage rate? This slide is really just nice to look at, but within it are key details, details on current CO2 injection projects around the world. It also shows today that we are injecting and storing across a wide range of geological formations. That includes different depths, anywhere from 600 meters down to 6 kilometers. Different types of rock types, carbonates, as well as sandstones. So that varies greatly around the world, but the industry has safely injected across different geologies. It's also injected across different geographies and environments. So from the onshore continental Europe in the LAC project that you see on the end there, through to the Petrobras project, where they're injecting from floating PSOs in 2,000 meters of water. They're injecting CO2 for enhanced oil recovery. That's an incredible feat of engineering, which gives me great hope for CCS to meet that gigaton scale. There's also different injection designs. We've got standard vertical injection or deviated wells as well, but the Gorgon project is the first to employ pressure management. So that's producing water out and then enabling more CO2 to be injected. And then there's the Tomokamai project, which is injecting from the onshore to the offshore. Another critical aspect is you can see that all these projects are injecting in different countries. So that's also often overlooked, but a critical part is the regulatory environment. So these countries have met the regulatory requirements of each of these projects, have met the regulatory requirements of each of these countries. Next slide, please. So there's three main storage options, and I'll go through this slide very quickly. Deep saline formations are volumetrically the largest and widely distributed. It's almost guaranteed that most countries will have a suitable deep saline formation available for CO2 storage. The second option is depleted oil and gas fields. These are fields that have been have had their hydrocarbons produced or almost all produced, and then the CO2 is injected. These are critical because they're proven reservoir seal pairs because they've held back a column of gas or oil. And there's often infrastructure in place which can lower the costs of the injection project. And then finally, there's enhanced oil recovery. Today, that provides a commercial return for CO2 injection and can be net negative, as we are starting to see with companies such as Oxy pursuing net negative emissions using direct air capture technology with enhanced oil recovery. Next slide, please. The final part is perhaps the most important, and that's monitoring the CO2 once it's in the ground. This provides not only regulatory confidence in being able to inject and store CO2, but also provides that social license to operate. If you can show the general public and decision makers that the CO2 can be safely stored and we can We know where it's moving and how it's going to move. That provides the real impetus for CCS to progress in people's backyard. The oil and gas industry has provided us with extensive knowledge of the movement of gas and fluids in the subsurface. So that is a no-brainer. We know how that works. And we're emerging with smarter and more autonomous monitoring technologies. Now, this slide represents just a quick snapshot of some of the technologies available in both the onshore and the offshore environment. But you can see that there's technologies available from the atmosphere all the way down to the subsurface. And most of that has been proven to be effective monitoring tools for CO2 storage. It's also important to identify at this point that there's a very, very low likelihood of leakage to the atmosphere. And anyone in this room that knows how hard it is to extract oil and gas, it's the same for CO2 once it's in the reservoir. Next slide, please. So CCS is vital to our Paris commitments. The Paris Agreement really set the standards for climate change and each climate change technology. Using the Paris Agreement commitments, and that was 2 degrees warming, aiming for 1.5 or lower. The IEA Sustainable Development Scenario rolled out just how much each technology has to play in its part. And it's important to emphasize that every technology is required to meet this massive task ahead of us, including carbon capture and storage. So this goes back to one of my original slides, and that's the opportunity of CCS. In 2050, we're going to need more than 2,000 capture facilities around the world operating, capturing CO2. And that emphasizes the need for the rapid rollout at the rate that is not being met today. Pipelines, over 200,000 kilometers of pipelines will need to be rolled out, and over 400 storage sites characterized, drilled and ready for CO2 storage and being used. So the annual build out rate today is, for storage sites in particular, is somewhere between 10 and 30 storage sites being made available between now and 2050. As you saw from my opening slides, we're only really averaging 1 or 2 per year. So a massive build out ahead of us. The task is available. We've shown that we can do it across a wide range of environments, and that the geology is available, and that it can be done safe and secure. Next slide, please. And coming to my final slide, and it's just my key points. So as I emphasized at the start, CCS has a wide range of applications across many industries, and it's a mature and well understood technology. The EOR industry in particular has shown that we can do carbon capture and the storage component effectively and safely. Under any deployment scenario, CCS is required, and especially when we move into net zero emissions, CCS becomes quite a critical tool. CCS is key to enabling is a key enabling technology for a clean energy future, especially in those hard to decarbonize industries, such as the steel and cement industry, or the petrochemical and chemical more broadly. And it also enables the continued use of gas and fossil fuels for several decades, which is already locked in. But CCS is emerging as the cornerstone for carbon dioxide removal, including direct air capture and bioenergy and CCS. And it is emerging very clearly. Its majority of my work today is on CCS's part in the hydrogen industry, producing hydrogen with zero emissions to also decarbonize sectors such as transport and industry. Final slide, please. So that's all I have today to present today. Once again, I thank you very much for the opportunity to present. I look forward to the panel discussion, and of course, for everything you need to know on carbon capture and storage, please visit the Global CCS Institute. Thank you.
Thank you, Chris. That's a really interesting presentation. I wonder if there's any question from the audience. If not, just a quick clarification. I mean, this question might sound naive, but I just, from a really layman point of view, with all this wonderful technologies presented and knowing that CCS is going to be very important in achieving decarbonization target, do you see technology as a potential barrier to the wide adoption of CCS, knowing that the different stage of technology development?
Yeah, certainly you could say undoubtedly that the transport and storage of CO2 is very mature, and technology is certainly not a barrier. With capture, I think it's more about becoming smarter and more efficient with the capture to bring down the total costs of CCS. So capture represents somewhere between 70 and 90% of the total costs of a CCS project. So it's really in the capture rate, the capture technology that we're going to see the furthest advances. And that's really exciting. And once again, as every technology out there, it shows that with deployment, you have more refined knowledge and more refined skills and more refined tools, which can be applied to capture. And the more deployment, you get those tools and skills and people coming into the industry.
Absolutely, definitely agree. The part of learning by doing really was something that we really hope to see in the future, right? So with timing constraint, let's move on to but thanks, Chris, for the presentation.
Thank you very much.
Yeah. We'll talk to you again in the panel. So let me introduce our next speaker again. So that's Professor Rachma Sule, who will be sharing with us the experience from Indonesia. Prof. Sule, floor is yours, please.
Okay, good morning. Thank you very much, Mr. Moderator, and also thank you very much for the Energy Studies Institute for hosting this webinar. In this opportunity, I would like to explain the activity related to the CCUS in Indonesia and future perspective. Next slide, please. So we understood currently we face two crises. First is related to the peak oil. So we are facing the declining of the oil production, and in the other hand, we face the climate change because of the huge amount of CO2 on the air. So that's why what we could do for this crisis. Next slide, please. We have learned in the past time that to stop the global warming, we could do several actions. First, increase energy efficiency. Second, increase renewable energy. And it could be follow with the decarbonization of power generations from fossil fuels. But we learned also from IEA in 2008 that the only technology available to mitigate greenhouse gas emission from large-scale fossil fuel usage is CCS. Next, please. That's why in Indonesia, the government has initiated to develop a so-called National Center of Excellence for CCS, CCUS, and zero routine flaring. The purpose of this establishment is first is to realize for the realization of national commitment to reduce greenhouse gas of 29% in 2030 by national effort, and it could be increased up to 41% if there is international support. And then secondly is to promote the reduction of greenhouse gas emission from energy sector in Indonesia. So our organization currently has so many activities related to the developing technology related to the CCS and CCUS, and then we starting with the develop of real project in Indonesia, and maybe someday we could extend our knowledge to develop to the implementation to the the other oil and gas field with the CO2 high CO2 content, such as Natuna the Alpha or other fields in Indonesia. And last year we already produced the draft of the presidential decree for supporting the CCS and CCUS activity in Indonesia. It is produced with the support from the Asian Development Bank. Next, please. If we talk about the activity of CCS and CCUS, actually we have started since the beginning of 2000. But our group at Institute Teknologi Bandung, we have studied related to the preparation of pilot project of CCS in Gundi Field. So Gundi Field is actually situated on the boundary between Central Java and East Java province. In this place, we could see there are three structures that produce gas. So the production is about 70 million scarf for 12 years, but unfortunately, 21% of the production is CO2, which is equivalent with about 800 tons per day. This photo on the right side is the current central processing plant, which is already on stream since 2016. Next slide, please. Historically, we studied about Gundi CCS projects since 2009 or 2010, and we received so many support from international, such as SATREPS project from Japan International Cooperation Agency and Japan Science and Technology Agency. Within this cooperation with Kyoto University, we work with the site selection and monitoring. And then in the between, we got also support from Asian Development Bank for supporting the surface facility study, and then support from Royal Norwegian Embassy for risk assessment. And we got also the other support from the other institutions such as Kansel Teknos and Indonesian government. And then until 2016, actually our intention is to inject a small amount of CO2, which is about 30 tons per day within 2 years. So the total of CO2 that will be injected is about 20,000 tons. So the purpose of the Gundi project in the beginning is to show to the Indonesian community and also international that CCS is applicable also in Indonesia, which is in the active tectonic region. But then since 2016, we changed our scenario in which we want to inject all the available CO2, which is 800 tons, to the deeper reservoir in Kujung Formation, to the active reservoir. So that activity are mostly supported by ADB in the framework of Knowledge Partnership Program. Next slide, please. This is shows the activity in the field. We asked our student also to join. We could see this is part of the seismic baseline survey in Japan structure. And then next slide, please. And finally, we could get a so-called seismic 3D cube from that survey. And we did also several other activities related to the research and education. Next slide, please. Okay, the new scenario of the Gundi CCS project is to inject 800 tons per day for 10 years. So it means that 3 million tons of CO2 will be stored in the active reservoir of Pujung. So we did also the reservoir simulation, as could be seen in the bottom left figures. And based on the reservoir simulation, we could see that if we inject totally 3 million tons of CO2, so the incremental reduction about 5.4% or equal to 36 BSCF. So of course, this is a good news because if we calculate with the current price of gas, it is equal to 100 million US dollar. But then we calculate also the cost for the capex and opex for 10 years, which is about 35 million US dollar. So basically, the CCUS in Indonesia is very applicable because the source of CO2 and the sink is close to each other. But then it attracts also foreign institution like Japanese government to implement a so-called joint crediting mechanism scheme. Next slide, please. So this is the current situation of the Gundi CCUS project. Currently, Janus and J-Power conducted a so-called pre-feasibility study for GCM together with us, and the scope of work could be seen in the table. The study should be finalized by February 2021. And then if the report that we prepare could satisfy the Japanese government, so the JCM funding could be given to us for the duration of 5 years, including to construct the additional facility for the CCUS. Next slide, please. The government of Indonesia mentioned also that the remaining oil in place is still huge, is about 63%. So maybe EOR or enhanced gas recovery is a good option in order to maintain our oil and gas production. And one of them is how about if we inject the CO2 for the EOR or EGR. Next slide, please. So that's why our group prepare the potential CO2 source and sink map from all around Indonesia. Here the red dots depict the source location and the green dot are the location of the sink. So if we make a zoom to a specific area in Sumatra, South Sumatra, please. Next slide. So we could see that there are so many CO2 sources and CO2 sink close one to the others. And we already classify also companies who operate those oil and gas or industry or coal-fired power plant. So we are starting to make some hub system for the CO2 management. Next slide, please. And then how about if we think about the CO2 from the coal-fired power plant? Because in Indonesia, we are blessed with the coal, and I think we have to be wise in using the coal for our electricity, especially. So that's why in the next slide, please. we could see how about if we combine the CO2 sources from power sector, from the coal and the sink in the surrounding area. This is a location in West Java. This power plant produced already 660 megawatt electricity, and the amount of CO2 is about 4 million tons per year. So that's why this is a good, a very big amount of CO2 that should be maintained by us. Next slide, please. And then Bioenergy Ccs is also one of our invention. We could see, we have learned that the CCS is zero emission actually. If we use coal combined with the CCS, it will be slightly zero emission. But if we implement Bioenergy CCS, it means that we could achieve negative emission. So that's why our group worked together in the Pacemaker project in order to start these projects starting from this year. Next slide, please. And then how about the flaring, the methane flaring or gas flaring? It should be also by us, because one of the target is how to monetize the flaring several location in Indonesia. Next slide, please. This should be the final presentation, the final slide for me. So I would like to introduce that our group will the IEA, GHG, and IED virtual course. Activity. So thank you very much for your kind attention. Next slide, please. And see you on the panel discussion. Thank you.
Thank you, Professor Lee, for the presentation. So it's really interesting, exciting to see pilot effort in Indonesia. In the interest of time, I will hold my questions and anyone else's question to the panel discussion. So please now let me reintroduce Professor Razlan Binjuni, who will be sharing with us the experience from Malaysia. Prof. Razlan, floor is yours, please.
Okay. Assalamualaikum and very good morning. Thank you for inviting me to present in this roundtable talk. Well, the title of my talk today, Malaysia Experience in Cultivating the Opportunity of Carbon Capture and Storage, or CCS. Next, please. Okay, this outline of my talk. I will start with the CO2 emission and also CCS activities in Malaysia, and then I will share about my research on CO2 storage assessment in Malaysia Basin, and then the last will be summary. Okay, next slide, please. Okay, so the first I'll talk about CO2 emission and also CCS activities in Malaysia. Next, please. All right. Well, today, all over the world, we experience what we call it global warming, which is rapid increase in Earth mean surface temperature. So if you can see from this graph, actually after year 60s up to today, we can get the rapid increase in our surface temperature. Well, this also happened to Malaysia. Well, we experience a warming trend as well, especially in our capital, Kuala Lumpur. So if you can see from this graph, from year 1961, the average temperature about 26.2 degrees Celsius, and it's jumped to 28.2 degrees Celsius in year 2018. So if you can see from here, about 2 degrees Celsius increase for the last 60 years. Okay, but as compared to the global trend, we can say 0.8 up to 1 degree Celsius. So it's worse in the capital, in Kuala Lumpur. Okay, next, please. Well, if you're looking for the CO2 emission in Malaysia, So how much in million tons? So it was 257.8 million ton CO2 emission in year 2018. Increase, I think, as compared to the previous year in 2017, it was about 246.5 million tons. So, well, from where this source of emission come from? Mainly from the energy, and followed by the mobility or traffic, and also from waste from landfill. But the majority from energy, but about 76% actually come from energy and also mobility. Well, at Paris Climate Conference in year 2015, Malaysia made a commitment to reduce by 2030 of its CO2 emission per unit GDP by 45% from the level of 2005. Okay, next please. Okay, here I list several activities related to the CO2 emission reduction and also CCS activities. So if you can see from this slide, since 2011, the government of Malaysia, via what we call a green tech, Malaysia established what we call as low carbon cities framework, or LCCF. So this LCCF is a national framework assessment system to guide and assess the development of the cities in Malaysia into low carbon cities, besides to promote green technology as well. Okay, in this framework, there are 5 elements. So one of this from the 5 elements is to increase carbon sequestration from protecting and also adding green spaces. Next, please. Okay, this another activity relate to the CO2 emission reduction and also CCS activities. So in 2010, the Malaysian CCS scoping study was carried out by Global CCS Institute with the collaboration with KETA, or Ministry of Energy, Green Technology and Water. So in the scoping, so they identify several main potential for sourcing clusters, but in here I highlight 2 of them, because based on the activities, the main activities, oil and gas, one in Eastern Peninsula Malaysia, which is cover Terengganu State, the activities oil and gas, especially in the area of what we call Kerteh and Paker. So from this, Terengganu State, which can access potential storage areas in the offshore, in the basin, what we call as Malay and Penyu Basin. So these 2 basins located in the east of the Peninsula Malaysia. So this another cluster from Sarawak, in Sarawak, which is especially in Bintulu area, or Bintulu town or city, which can access potential storage area in the offshore Greater Sarawak, or what we call as Sarawak Basin. Okay. And besides, they also explore the legal and regulatory aspect of implementing CCS in Malaysia. Okay, next please. Okay, this is the activity of using low emission coal technology. So one of the good example is TNB. So TNB stands for the Tenaga Nasional Berhad, which is one of that electricity company in Malaysia. So in this TNB Manjung 4, because there are 3 before this, so now it's become number 4. Manjung 4 is considered first ultra supercritical coal-fired power plant. Started its commercial operation in April 2015. So by using this technology, so they can reduce CO2 emission by as much as 35% as compared to the older plant. All right. Next, please. Okay, this is another activity as well in CCS in Malaysia. Actually, Petronas already identified there are 15 offshore gas fields high in CO2 content. So in order to sustain for Malaysia to be a natural gas producer and also an exporter, so they need to develop this gas field. So in early of this year, Petronas has signed an agreement with Japan Oil, Gas, Metal National Corporation, or JOGMEC, and also beside I think Nippon Oil. So in this study, they will develop this high field by using that CCS technology. So basically, by CCS, the CO2 from this field, they will separate, and then capture and afterward inject or store in the mature and also depleted gas reservoir. Next, please. What? Sorry, I think it is a map. It's missing, right? Okay, actually, in conjunction of this called CO2 field development, so Petronas has been identified the potential credit for CO2 sequestration site, actually located in the offshore of Sarawak. Okay, and also Petronas already conduct 3D simulation analysis, basically to identify the effective storage capacity in that candidate field. Actually, from the map, actually to show that where is the gas field they want to develop, and also the location of that candidate field to be injected for that CO2 storage. Actually, it's located about 170 kilometers away, okay, from that high CO2 field. Okay, next, please. Okay, actually, in the coming slide, I'd like to share my experience, my research experience in CO2 storage assessment in Malaysia. Okay, next, please. All right. Actually, the objective or the main aim of the study was to evaluate suitability, site suitability of potential CO2 storage in Malaysia in sedimentary basin, and then to estimate the potential CO2 storage capacity. But we focus in this in deep saline aquifer. Actually, actually in this study consists of 3 parts. Part 1 actually consists of preliminary screening and ranking of sedimentary basin in Malaysia to be possible for CO2 storage. And then part 2, mapping of potential area in sedimentary basin by using ArcGIS. And then part 3, to do the basin evaluation and also to calculate the storage capacity in most, in the rice banking, in rice ranking from this basin. Okay, next, please. Okay, basically, as I said, we focus to inject to the saline aquifer. Next, please. Okay, this is a method by using what we call it screening criteria based on the BACU 2003. So there are 13 criteria we use from tectonic setting, faulting intensity, reservoir seal pair, depth, size, and so on until the climate. And then we divide by the classes. There are 5 classes, 1, 2, 3, and next slide, I think, because of the big slide. So sorry, big graph, big table. I divide to 2 slides. All right. So there's a class 4 and class 5. For example, for tectonic setting, so we divide. Can you please go back slide, please? All right. for example, tectonic setting. So class, for example, four arc. So this actually the basin type can be four arc, can be bare arc, can be platform, and also we consider delta and also reef basin. So for each classes, we give the score. All right. For each of the criteria, criterion. All right. Next, please.
Sorry,
okay, next, please.
we need to. You're running out of time.
Okay. Right. Okay. Next, please. Okay. This calculate the equation we use for storage capacity. Next, please. Okay. These are the result of the ranking of sanitary basin in Malaysia. So based on that screening, so from this we rank the basin. So the best basin according to this screening and ranking. So the Malay basin is going to be the best, and then followed by the central local province in Sarawak. Okay, next please. Okay, this the map to show that the basin potential for can be high potential, low potential. For example, in this case, for example, Malay basin and also central local basin is considered the best, or we can say high potential for the CO2 storage. Next, please. Okay, this to show the stratigraphy in Malay basin and also central local basin. So actually the best in this study to store from 1,000 meters to 1,500 meters. Okay, next please. Okay, this is the result of that CO2 storage capacity can be stored in Malay basin and also central local basin. Next, please. Okay, actually, beside that geological storage, okay, have done the research as well for mineral carbonation. I think if you can see from here, we use mineral carbonation because this we get from waste from for the production of titanium white pigment. So we did this study in this mini reactor or autoclave mini reactor, and at certain temperature and pressure, so we can produce the carbonate product. I think it's good for Singapore, for example, if because you don't have any basin, because you can try with this mineral carbonation. Can be from the waste or can be from that waste concrete and so on. But the most important, high in calcium and magnesium from this material. Oh, all right. Okay, next, please. Okay, next, please. Okay, with this, I'd like to summarize from this talk. Actually, in 2018, Malaysia emitted 257.8 million tons. So the energy sector is the biggest emitter. And then with current technology, Malaysia will be able to develop an offshore field with high CO2 content, gas field. And then Malay Basin and also Central Local Basin is considered the top 2 in the ranking. And then the result, I mean the potential CO2 to be stored in these 2 is about 21 gigaton and 14 gigaton of CO2 respectively. Okay, thank you. That's all.
Thank you, Professor Sun, for your presentation. We're slightly running over time, so
right, okay.
Allow me just to introduce Dr. Ganesh Dasari, who will be the last speaker for today on his topic. So Ganesh, floor is yours, please.
Thank you. Thank you for hosting this event, and also thank you for inviting us. So as you heard the first 3, so we started with the sort of the global overview of the CCS projects, and then we heard a little bit on the Indonesia and then Malaysia recently. So now what I want to do here is take a perspective from an industry perspective, like obviously we have slightly, we exactly think about the same problems, but in a different perspective. So what I want to share today here is what ExxonMobil is doing globally to develop the required technologies for CCS to be successful. But also, more importantly, I want to talk about what are we doing locally in Singapore, in the ASEAN region, to help develop the CCS projects. So if you go to the next slide, please. So I think I don't need to belabor this point, but again, I just wanted to re-emphasize. So you heard from the first three speakers. The world needs to move on to the decarbonization. So that's clear for all of us. Now the next immediate question here is, do we need CCS, or can we achieve that goal without CCS? I mean, this is obviously question that we ask internally many times, and then we do our own internal work, but also we look for some of the external models. So what you're looking at here is on the left-hand side, a graph which is there are some set of curves on the top and then some set of curves on the bottom. So each of those corresponds to one climate model. So these are world experts in modeling climate change. So the top set of curves basically shows that how much CO2 will be emitted if we don't do anything. So we just follow the current business as usual. And the bottom set of curves shows like how much CO2 that we need to abate in order to reach that 450 ppm or 2 degree scenario. So this is what Chris started at the beginning. So again, these numbers will put the same thing in a better perspective. So if you look at the right-hand side figure, so what it is showing here is a snapshot of various energies that will be used in 2040, so that's 20 years from now, with various models. So at the bottom of the chart, you'll see different models. So each of these corresponds to one group. These are obviously the world experts who model these things. But a couple of takeaways. I want you to focus on though the magnitudes are different, but they convey one thing. If you look at the word CCS, oil with CCS, natural gas with CCS, or coal with CCS, or bioenergy with CCS, so all of these models basically see a role for CCS in order to reach this 2 degree scenario. So now so now you see the role, but how much is it? I think this is what also Chris was alluding to. If you take that yellow line, which is shown on the left-hand side, so by 2040, basically, if you take a mean value of the black curves and mean value of gray curves, that translates to roughly about 4 gigatons per year. You may not appreciate what 4 gigatons per year is, but that is the entire hydrocarbon industry as of today. So that is the size of the CCS industry has to be within like short 20 years. It's not easy. I mean, it took a long time to develop the present hydrocarbon industry to this size, and then that has to be achieved in the next 20 years. So it's a daunting task for the CCS. But you can look at other way, it's an opportunity as well. So next slide, please. So what is ExxonMobil doing to sort of make CCS reality? So first, I think you also heard from the panelists that the capture is one of the most expensive, and also we need to sort of understand that one. So ExxonMobil is working on developing the next generation capture technologies. The first one shown on this slide here is a fuel cell. So this is the work done in a company in collaboration with the Fuel Cell Inc. So in a simplistic terms, this fuel cell essentially takes the flue gas, which has a CO2, so that flue gas could come from a power plant, coal plant, and then combine that with the natural gas. As an output, what you get is electricity so that you can use, but also you get very high concentration CO2, which you can use it for CCS industry. So we believe that this will change the capture technology in a much more efficient way at a reduced cost. And to give you another example, we are also working with what is Mosaic Materials. So this is a company who is specialist, makes new materials. So now we are essentially combining with ExxonMobil, also has a material group. So we are combining our strength with Mosaic Materials to develop next generation capture materials. So these materials will capture CO2 at much reduced cost than what we can do today. So I don't necessarily need to spend time on rest of the technologies, but I think the key message here is we are doing internal research as well as we are collaborating with research companies and the universities. The main aim here is to generate the next generation technologies which can help CCS industry globally. So that's the global scene. So if you move to the next slide, please. So what are we doing locally in Singapore? So as you heard, Victor introduced this one. So there is a Singapore Energy Center started in 2018, and ExxonMobil is a founding member of this energy center. So as part of this energy center, so there are some core projects. So this is essentially the core research projects that universities and ExxonMobil as a founding member companies agreed. And then on the left-hand side, you'll see like ExxonMobil collaborating on some specific topics that are interest to us. So I'll give you a couple of examples. The first one on the top left-hand side is novel membranes. So again, with the help from the researchers from NUS, we are developing the membranes to sort of capture CO2. And then there are other technologies that you can read. So I'm not necessarily going to spend a lot of time each of this one, but I would also say that if you're interested in what Energy Center is working on, you can actually visit Energy Center. Their website information is on the slide, or you can Google Singapore Energy Center and then you'll get there. And then you can see this range of technologies with a lot more details that we are working. So the point here is, I think, besides working on at a global level, but also we are working locally to understand the local challenges better, and then also coming out with solutions, taking advantage of the expertise available in Singapore. Okay, if you go to the next slide, please. So one of the projects that was on the previous slide as well, so this is where we are spending a lot of time. What we call here is a regional CCS study to develop the quantitative understanding of storage transport policy. So as you heard from the previous speakers as well, so if you want to do CCS project in any part of the world, first thing here is you want to know how much storage is there. And Duan mentioned that there is a 35 gigatons of storage capacity in Malaysia, etc. And so what we are trying to do here is we are trying to take advantage of all those sort of studies that are available and then aggregate that information and then look from a regional perspective. So, okay, so how much storage capacity is there? Where is the storage capacity and how much does it cost? So as you can imagine from an industry, the cost is always one of the important things, right? So it's not just sufficient saying that there is space, but we need to know how much does it cost. So so that's what we are trying to do on the first part, which is the geosequestration storage. So regionally, how much storage capacity is there, where is it, and how much does it cost to store CO2 in those formations? The second piece, what you see here is the transportation options and costs. So as you know, the sources, the CO2 sources will be at one place and sinks will be at a different place. So how do you connect these sources and sinks? So this is where what we are looking at is what are the technologies that are available depending on what scenario that we are looking at. And then again, how much does it cost to move source from CO2 from the source to sink? And then also as part of that, can we use existing infrastructure? What infrastructure is available? And then can we use it for doing for CO2? So again, that's depends on the place. So this is obviously we are doing it in the ASEAN regional context. The third piece here is the policy regulations. First of all, we want to understand what sort of policies exist in this part of the world to enable CCS projects. Then if there are not much available, then also we are trying to understand what can we do to help establish these policies, regulatory framework, so that the companies can start, countries can start thinking about how to arrive at a policy regulatory framework so that CCS industry can flourish. Okay, if you go to the next slide, please. So I want to spend a few minutes on the storage aspect, like how do we evaluate how much storage capacity is there? So so you also heard the storage capacity is available in oil and gas fields as well as in the deep saline formations. So far into this study, we have only completed the first piece, which is how much storage capacity is available in the existing oil and gas fields. So obviously, we are also working on the how much storage capacity is available in the deep saline formations, but that will be shared at a later time. So the way we have done here is we know that where these oil and gas fields are, and then we know what is how much has been produced. So these are really hard numbers. So because the location is known, how much you produce, that's an information that's is available. So once we have that information, these locations, so we compile that. So we have several thousand oil and gas fields in this part of the world. You'll see a map in the next slide, but then not all the fields are suitable for storing CO2 because you want to make sure that the stored CO2 stays in the subsurface for a very, very, very long time. It's not going to come back. So which means it has to satisfy a certain criteria. In fact, when we applied that criteria, which is shown on the slide, to these several tens of thousands of fields, we only ended up about 150 fields. So those are actually our first cut, so which are suitable, which we feel confident about that we can really store CO2 in those fields. And then we apply a methodology similar to a methodology that Prof. Rajwan showed in the previous slide, what is called the USGS, the United States Geological Society storage method. And then we use that method to compute how much storage capacity is available. Okay, if you go to the next slide, please. So I just wanted to share some of the early results from the work that's ongoing. So first, I want to focus on the left-hand side map. So what you're looking at here is the storage capacity available in each of the countries that we studied. So it's shown in as a bubble. So what we have done is we took all the oil and gas fields in a given country and then essentially showing as a big bubble to that one country. It doesn't mean that that's where all the storage capacity is there. Just for the sake of easiness to demonstrate, we combined all the country into one bubble. So for the scale, it's given on the left-hand side. So 10 gigatons will be that scale. So as you can see, Indonesia obviously has close to 18 gigatons. Malaysia has about 12 gigatons. Myanmar has about 15, and Brunei has about 7 gigatons. So don't confuse with these numbers with what Prof. Rajwan showed, because he was showing both oil and gas fields and saline aquifers. So what I'm showing here is just the oil and gas fields. So from the discussion so far, so it's intuitive for you by now that actually if you add the saline storage to these numbers, the storage numbers will be much bigger. So, but this is the data that we looked at. We feel pretty confident about it. Let's say that's the storage capacity available. Just accept that for a minute. And then if you look at on the right-hand side, the table, so this is 2018 emission data. So if you add all the countries, you get about 1.3 gigatons. Then not all are all going to be used by CCS, because you have energy efficiencies, renewables, and other things you can use to mitigate. So let's say 25% of that is going to be used by CCS. And then if you took the 60 gigatons and that 25% of the 38, you get about 250 years of storage. So the message here is there is a lot of storage capacity. So that's not the worry here at all. So we need to figure out how to efficiently do it. So if you go to the next slide, please. Okay, so now once we feel confident about that there is enough storage capacity, so now how do you move from the sources to the sinks? Sources being what is producing CO2, sink being the site, the geological site, which is accepting CO2. So what we are looking at here is the pipelines. So as most of you know that transporting pipelines at the scale that we are interested, so we are talking about millions of tons, is feasible. So it's a reasonably proven technology. But as the distances increase, pipeline costs will increase. So we are also looking at, can we transport CO2 by ships? So unfortunately, ships you cannot transport at the same pressure as the pipelines, because the size, simply the technology is not available. But then we started thinking about what else can we do here. So then we realized that actually at the triple point of this phase diagram that is shown on the top right-hand side, that's a phase diagram of CO2. But what happens there is the CO2 volume dramatically decreases. In the gas state, you have a lot of volume, but once you cross the triple point, go to the liquid, the volume decreases. So which means it's convenient to transport CO2 in the ships because the volume has suddenly decreased. So then we started looking at, are there any existing ships that we can use to transport CO2? So the answer seems to be yes. With simple modifications, we can use the existing ships to transport CO2. So with these ones, we feel confident that there is a technology which is a pipeline, and then also the shipping technology available. And then at the left-hand side, right-hand side bottom, you can also see the relative costs. So obviously the pipeline will be cheaper if the distances are small, but if the distances are long, then the shipping becomes cheaper. So we can take this information. So now we have storage capacity, locations, and you have transportation options, transportation costs. Then we can start matching, like sourcing matching. Okay, if I want to take CO2 from one place to the nearest, most cost-effective sink, where is it and how much does it cost? So we need to do that. So we are essentially doing that. We are building those building blocks so that that information is going to be available. Okay, if you go to the next one, it's my final slide. So again, I just wanted to summarize. CCS, like most other speakers also highlighted, we believe that CCS will play a significant role in mitigating greenhouse gases worldwide. And this region is not going to be exception. So we feel that this is going to be part of here. So as we watch how the various greenhouse gas mitigation technologies are evolving in various countries, CCS is a part of that. And we think as the region starts thinking about decarbonization, so CCS will come and play a role. As I showed here, like again, others also contributed to this one. So this part of the region has a lot of subsurface storage capacity. So that's a good news. So now how to make effectively use of it is the challenge. We don't need to look for these places actually. Then in terms of transportation, so this is evolving very fast. So as I said, pipelines are proven, but shipping also coming. So because shipping has certain advantages, so you have a lot more flexibility. You can, if you don't, you can go, you can store CO2 at one place for 10 years, and then you can go to the next one. With a pipeline, obviously you can't do that. We believe that especially for the distances that going to be typical within ASEAN region, shipping is going to be available too. And as far as Singapore is concerned, so obviously taking a very proactive role here, and then it can help kickstart CCS in this part of the world. Thank you, Victor.
Right. Thank you, Ganesh. And thank you, everybody, for the wonderful presentations. They are really interesting. So what I want to do now is to jump straight into our panel discussion. So could I invite all the panelists to please switch your camera back on so we can have the panel discussion. Right. So really interesting. So what I wanted to do is I want to go straight into the questions. And then after we have the panel discussion, I would like to leave a few minutes for each one of us to just give a quick roundup. And then perhaps at the final stage, I would probably invite Dr. Ganesh to give a few words. Now, just going back to most of our slides, the speakers from Chris, from Prof. Razan, from Prof. Sule, it is almost unanimous that 1.5 degree, 2 degree, whatever that commitment that we're committing, CCS needs to play a role, right? So now if I were to go back to Chris and of course also Ian from the GCCS side, we already know that there is this potential contribution by CCS, right, in attaining the Paris Accord. So what really is preventing CCS from a massive adoption? I mean, in Chris' slide, you see there's actually a slowdown just within the past decade, and then there's a gradual taking up. So what really is preventing it? I mean, there's technology factors, but what is there, that's just preventing us from rapidly going into CCS? Chris, you want to start?
Yes, well, it's clear from the Global Institute, from our policy studies and wider studies, that technology is not a barrier for the deployment of CCS. We know where CCS can happen, and we know that we can capture, transport, and store CO2. The major barrier to deployment these days it's for the wider climate technology community. Its policy is a barrier. Having a policy in place that either puts the value of carbon on the emissions of CO2 will enable not only carbon capture and storage, but generally all technologies in the climate change space. Ian, if you have any more notes.
Thanks, Chris. Yeah, no, I'd echo what Chris says. I think it's less of a technology story, more of a policy story. I think the slowdown that Chris highlighted in his slide from 2011 to sort of about 2016, it was a pretty clear story around the availability of money from governments and industry to support CCS. We've seen an increase more recently, 2015 onwards, partly because of a recovering economy, but also because of national approaches post-Paris. We've had a strong commitment from the international community to reduce emissions and take that step beyond 2020 onwards. And we've seen a number of countries now making explicit commitments to net zero. The Japanese government just 2 days ago, for example. What we need further, though, is explicit commitments to carbon capture and storage within those within that mitigation ambition. And what we're starting to see that in some jurisdictions. But as Chris pointed out, until we get either a supportive mechanism in terms of a price on carbon, for example, or there's a range of options, to be honest, industry is going to be reluctant to commit the funds towards investing in the technology. And government, quite frankly, isn't going to achieve that mitigation ambition that it has. And we see that in some of the figures that in the slides from the IEA, for example.
And if I could just make one further point, from the analysis that Ian and I have undertaken around the world, what we've really seen is that having characterized storage in a country and then supportive and encouraging regulatory environment really helps private industry, particularly drive CCS in that country. Because without those two aspects, known storage sites and a regulatory framework, really private industry can't move forward.
Right. I think that's really a very interesting point. I mean, thank you, Ian and Chris, for pointing that out. So now I just really want to, point to our colleagues from ExxonMobil, Dr. Ganesh and Dr. Adam. I really want to hear your views, from the perspective of decarbonization, whether be it government, industry, or the project implementers, cost is always an important. I think Ganesh already, in a way, hinted that actually cost is a very important consideration, especially now we're doing a public good in decarbonization. So, just, from a really naive point of view, how does CCS fare today? The region is doing renewables, energy efficiency, these are well known, right, to us. We're doing all that. So how does CCS, in terms of cost competitiveness, in this map of decarbonization, in your view, from the private industry?
I guess this is Adam, and CCS compares favorably for large-scale CO2 mitigation. I think several, Chris and several of the panelists presented some evidence that, using models that, look at costs of different mitigation pathways. And I think that the consensus amongst the energy studies modeling community is that, first of all, you're going to need all different technologies. The cost curves need to come down for all of them. But for large-scale CO2 mitigation, over the next 20, 30 years, CCS is cost competitive. Now, what Ganesh pointed out is that there's, in many cases, the capture part is the most expensive, particularly from low concentration sources. So a lot of our R&D, at fundamental science and engineering is focused on the low concentration CO2 sources. For example, a natural gas power plant, the emissions, the flue stream, the concentration of CO2 is very, very small, 4 or 5%. And it's ironic because natural gas power is so good from an emissions point of view per kilowatt hour of electricity generated compared to a lot of other sources. But it actually, that very advantage makes it harder to capture the CO2. So I think our thinking is that we would go for the high concentration sources of CO2. Those will be the cheapest to capture, and then work through the transport and sequestration options. That are probably the first projects to go from a purely CO2 mitigation point of view. And then as the technology progresses and the cost curves of low concentration CO2 come down, we can then attack really the elephant in the room, which is power generation, and reduce the cost there well. And in that, and our view is that it will be part of the mix. It will not be the solution to CO2 mitigation, but it's going to be an important part of the mix.
Thanks, Adam. Anything, Ganesh, you would like to add?
Yeah, so again, I think if you talk in terms of general broadly, CCS is quite competitive with all of the technologies. But again, I think all of us emphasize that it's not like one versus the other. So probably we need all of these technologies because the size of the problem is so big that it's not like one technology can solve everything. But having said that one, in fact, depending on the policy and depending on the other circumstances, in fact, sometimes the CO2 can be so cheap. So for example, you have a high purity CO2 stream. So you didn't need to spend any money on capturing because this is already high purity stream. And then it so happened that the storage place is right below your industrial facility. And in fact, there are a couple of like IBDB, the Illinois Decatur Basin Project, they're just injecting right into the same campus. So in those scenarios, CCS can be a lot cheaper than anything that's available.
That's a very interesting point. Thank you. So, knowing the benefits and the potential applications, and even knowing that where we are today. So now I want to direct the questions to our professors from Indonesia and Malaysia. So maybe I can start with Prof. Sule. So, with today's technology, with your work and your experience involving CO2 storage and carbon capture, if I were to ask you, the top 3 pressing challenges or concerns in the current CCS effort in Indonesia, what would they be? And then, what do you think as an expert could be done within the country to mitigate or address those challenges?
Okay, thank you very much for the question. What we face in Indonesia currently is that CCS could not be part of the national commitment for reducing of carbon emission, but it could be part as the additional commitment if there is international support. So what we are trying right now is to connect the sources and the sink, because in Indonesia we have a lot of depleted oil and gas reservoir, and again the distance between the sources and the sink are very close. As Ganesh already mentioned, the CCUS activity in Indonesia could be very very economically. Based on our experience with the Gundi, we calculate that the cost for injecting 1 ton CO2 is about $11.7. Yeah, so it is not so expensive, but we could offer also this project like for the JCM from Japan or the other form of bilateral offset credit mechanism. So at the end, the player, the industry, could get benefit from the incremental oil and gas production because of the CO2 injection. The benefit could be get more from the carbon credit, and for the country and for the industry it is good because the facility will be very environmental friendly. Okay, this is my point. Thank you.
Right. Thank you, Prof. Sule. I think that's really interesting. Just to follow up on that on the Gundi project, this is you have a Japanese partner involved with technologies and presumably with funding. So this is under JCM. So what do you see could be the future of it? I mean, is this going to be like a future business model for the CCS implementation in Indonesia, where you would always have, I won't say always, but you would have an international partner in a way providing kind of international support, be it funding or technology, to actually bring CCS into your INDC commitment? Is this the way forward, or do you see, Indonesian private industry is also, taking initiative, or maybe together with the government, to move this forward? What is the future like in your opinion?
Currently, the National Center of Excellence encourage all the industries to aware with the CCUS in Indonesia, and it could be not a cost center. Yeah, this is the first point we deliver always to our friends within Indonesia. And then what we do is to make a joint study to try to connect their CO2 sources with the surrounding area. Yeah, and then what we try to give also to them is that maybe the involvement from the international support, like Japanese already give to us for Gundi in the JCM scheme, could be imitated also for the other international support. Unfortunately, we didn't know right now whether there is a kind of bilateral offset mechanism could be offered by the other country. Yeah, but basically, if there is no international support, CCUS in Indonesia could be not as a cost center. It could be a advantage project. Yeah. Okay. Thank you.
Thank you. So thank you, Prof. Sule. So I think the same questions, to Prof. Razwan, whereas, in comparison in Malaysia, based on our understanding from our study, we see a lot of good effort from Petronas. They're actually looking into the K5 greenfield CCS. We didn't really see much of international support being mentioned. I believe there would be. I mean, there might be. Correct me if I'm wrong. So, do you see that? If I were to ask the same question as I asked to Prof. Sule, to Prof. Razdan, what do you foresee as the most pressing challenges of massive scale rolling out of CCS in Malaysia, to achieve your decarbonization target?
Okay, thank you, Dr. Victor. All right, I think the main challenge CCS in Malaysia, I think the first about the policy or the legal. I think there is no legal on CCS in Malaysia yet. Yes, but anyway, I think initiated by GCS Institute and also Ministry of Energy, but until now there is no legal in terms of the CCS. Okay, I think this is the main challenge. All right, as you said, Petronas already initiate, because in order for Malaysia or Petronas to be sustained in terms of in the production of the gas and also to be net exporter, so they need to develop for the new gas field, which is high in CO2. So, as I said in the presentation just now, early this year, Petronas and also with Japan company, with the Nippon Oil. So now they are doing or initiate the study to develop this new high in, the new gas field, but high in CO2, but some with high as much as 70% of CO2. So they need to develop that in order to be sustained in CO2 production. Okay, thank you, Dr.
So just to follow up, on the K5 greenfield question, project. Yes, we're aware that there is government involvement in the project, but what we are not very sure. This is is a follow-up question. So is that project actually falling under the JCM, or is just a special arrangement, joint credit mechanism, meaning it's like Japan's way of decarbonizing the country, where they invest in low carbon technologies in the region. So is that under that part of the scheme, or is just company to company, like private arrangement with some support from government? So,
all right, you estimate, Dr. Victor?
Yes.
Okay. I have no idea about that in terms of that company to company in Malaysia about the CCS.
Okay. Yeah. No problem. No problem. I mean, it's just curious because we see a lot of good effort by Petronas, and we were just wondering whether that is the kind of model to go. You involve a partner rather than directly introducing a mechanism into the country. Kind of like using internal your own funds to support CCS activities. So I guess that's something that we will probably be keeping in touch and have further conversations. So, but you did, Prof. Robson, you did bring a very interesting point, which I now want to go back to Ian and just ask this question that that's been in my mind for quite some time. We always believe the technology should be there, when we need it. So now what I'm hearing from the region is that there is also a lack in the legal and regulatory development. So, in your opinion, do you see that as a potential deal breaker? If let's say we have no basis of law, no basis of regulation to reference to or to comply with, do you actually see that as a deal breaker for technologies like CCS, where there is no law, regulation, or even policy around it? What is your view on that?
In short, yes, I do see it as somewhat of a deal breaker. And as Chris mentioned previously, one of the things that he and I work on are a range of indicators for the Institute that look at performance of individual countries across storage, legal and regulatory policy, and then readiness. But I mean, I'm a lawyer, so I look at how a project like this is going to be regulated is just of interest to me. But I mean, I think it's pretty clear in those jurisdictions around the world where we've seen projects go ahead or have been successful, or we've seen you know, strong investment. There is a legal and regulatory framework which supports that project. I mean, that's undeniable. I mean, I look here in Australia, the Gorgon project, which is the major Chevron supported project here in Western Australia. We have a piece of project specific legislation that was a cornerstone of supporting that project going ahead. I think one of the interesting features of the Southeast Asia region is if you look at the existing regulatory frameworks that support oil and gas activities, perhaps in each of these individual jurisdictions, there are elements of those existing frameworks which would support perhaps a one-off program, or in many cases, certainly enhanced oil recovery or enhanced gas recovery activities. The challenge is, from my perspective, the sustainability of building an entire industry. And that's really what's required across Southeast Asia, the CCS. To sustain an industry of the size that we hope for, you're going to need more than just a sort of piecemeal approach. Now, whether that is project-specific legislation in a particular jurisdiction, whether it's a CCS-specific standalone framework, or whether it's some sort of regional agreement, I'm agnostic. I think it certainly depends upon the individual jurisdictions, but I do see it as an intrinsic part of the policy response, and certainly key to getting CCS up and running.
Maybe Victor, can I jump into that one? So,
yeah, sure.
Ian, do you see an alternative mechanism? So obviously having this broad policy regulation without any project is tall order, because if you look at the existing oil and gas industry regulation, it took a while to develop it. It's not like you had that regulation on day one and then suddenly people started injecting drilling wells, right? So alternative model is like, if there are two interested parties who want to do CCS project, so they establish a policy framework, and then the regulatory framework will develop. In the first two projects, it won't be perfect, but with the few projects, it will become perfect. And then that's how it evolves. So I see this as like what you're saying, like to happen at large scale industry, you got to have this policy. But the initial projects probably could happen without them, and then policy and regulatory framework co-develops with the projects.
Yeah, I think that's a very good point. And I, as I said, I think for initial projects, certainly, and Professor Sule will probably confirm this, but in my understanding is in Indonesia, you could regulate a project presently, certainly of the type that we've seen in Gundi under existing oil and gas legislation.
Correct.
I think the challenge is filling the outstanding gaps, those issues which are completely novel to CCS, that are really quite important. If you even in first of a kind project, so things like long-term liability, for example, some of the monitoring requirements, and indeed sort of consistency throughout the permitting process. Those are all potentially relatively simple fixes. I say that very generally, but yeah, you're correct. That might be a sustainable approach, particularly here in Southeast Asia, for those early projects.
If I could add some information, so basically the challenge for us is to provide MRV methodology for a specific project, and we have to convince the government, the player, and also international community that our project is safe, and the liability issue is also the main concern also in the future. Yeah.
Yes. So now that we're coming very close to the region. So if I may ask a question that is very Singapore oriented, I think if that's acceptable. We talk a lot about this CDM, Article 6 or GCM, which is generating credit. And actually, Prof. Rodzan already pointed out in his presentation that if Singapore were to do a carbon capture, we have no place to store CO2. If you just pump under the water, I think the fish will probably complain. You don't pump CO2 into my backyard. So now, if with this notion of don't pump CO2 into my backyard, it's a general question to the panel. Feel free to chip in. If we're talking about a kind of regional or bilateral arrangement between a country like Singapore, who doesn't really have storage space, but we have a lot of CO2 that we want to figure out how we can capture and store them, and looking at the region, what is the possible mechanisms, or what do you foresee as possible avenues for the region to collectively benefit from CO2 storage reservoir that we are all looking at, in Indonesia, Malaysia, and also there's activities in Thailand, Vietnam. What do you see as possible ways, to push this CCS agenda forward as a region rather than just individual countries? I mean, of course, you want to reduce our carbon emission as individual countries, that's understood. But as a region, what can we do, in your opinion?
Maybe I can start with this. I'll just touch on one point and then others can jump in. Maybe one place to start this one is look for a win-win situation. So you have CO2 already captured, and then there may be some other country who may want to use it for something else. In this case, I can think of like EOR, enhanced oil recovery, comes as a so if we can find some place where it can be used, and then Singapore wants to get rid of CO2, and then other place wants to receive CO2 and use it, so that's a win-win situation. So obviously there may be some opportunities that Singapore could explore.
May I add just, we heard today from Dr. Sule and Dr. Radzwan, really interesting and aggressive, plans to doing in-country CCS, which is great. And in a potential ASEAN CCS supply chain, if it developed, this win-win scenario that Ganesh just described could help offset the costs of some of those projects. Because if, for example, CO2 from Singapore or Vietnam or wherever could be sequestered in a field which had sufficient capacity to handle both the needs of Indonesia and Malaysia and Singapore, then the right incentives could actually help make the costs for those individual countries much cheaper to do CCS. And that's an example of a win-win.
May I add one more thing as well?
Sure.
I mean, I think it's an interesting scenario, and we've seen in other parts of the world similar issues being discussed, and there's some nice analogies potentially, although slightly more advanced, in the model that's being proposed in the North Sea at the moment, the Longship project out of Norway, and the proposed link up between the sort of hub cluster model in the UK as well. There's clearly countries within Europe that won't have opportunities for onshore storage for various reasons. There's interest obviously in shipping CO2 or transporting CO2 for storage within Norwegian waters. Slightly goes back to my previous answer to Ganesh's question around whether legislation is necessary. What you can see from those examples is that there is a whole package, a suite of policies, regulations that have all needed to be in place to support that. So while I say, initial projects in country, you might be able to get by with existing models, to develop something of the nature that we're talking about here for Singapore to export or to share CO2 across boundaries or develop an industry, we're going to need the sort of policy prerequisites that support all that. And indeed, when we come to some of the mechanisms that are going to finance that, or the credits that are going to be generated from that as well. Yeah, just one more thought.
Yeah, interesting. Any input from our panelists? Because I'm reading, from the questions from the audience, I'm really finding something really interesting. Maybe I will just read out the questions. So, we see a lot of mentioning in our speaker slides on EOR. I'm not, I graduated from engineering background, but I'm no longer doing engineering. So it seems that EOR is something that is, fairly friendly. I mean, it's a way that we already know we're doing a lot in the region. So the question from this question from ASAR is, what could be an estimated contribution of CO2 EOR in CO2 storage globally, as well as in Southeast Asian region? So this question is directed at Chris.
Sorry, I lost you for a little bit there.
Okay, so the question is, what could be an estimated contribution of CO2 EOR in CO2 storage globally, as well as in Southeast Asian region?
Yeah, actually, Ganesh is probably best to answer this question, having just gone through such a study. I know globally, volumetrically, deep saline formations are much larger, just because they're more common. The geology is more common. You only need a saline formation, a reservoir, and then a sealing unit on top. Whereas with enhanced oil recovery, you need a particular oil type and particular reservoir conditions as well. So for that instance, it's much more rare to have those two aspects lining up. But I'm sure Ganesh can certainly answer to that much more authoritatively.
I'm not sure authoritatively, but I can answer that. So globally, I think it's several billion barrels that can be produced with CO2 EOR. So whether obviously it's like it depends on a lot of variables. It's like what's the oil price and etc. So these numbers tend to change a lot. Obviously, the higher the oil price, then you could get a lot more oil out of the ground. And also added to that, what's the carbon tax? So because while doing EOR, you can store actually CO2. So that also is a variable. But I think the short answer is globally, there is billions of barrels. How many billions? I think that's difficult to answer. But I didn't talk about during the talk, but we are also working on in the ASEAN region, which are the fields which are suitable for EOR project, because we have a criteria that has to be satisfied. So we have a technical answer, which is in the how much CO2 EOR can be obtained by doing the CO2 projects. But we are not, so that's close to about 800 million barrels or something with just the current estimate, but that number is going to change. But we also need to put some other incentives, other variables like the cost of the oil, cost of the CO2 and all those things. So, but technically, I think we are talking about 800 million barrels or so, if you're looking for an approximate number in this part of the world.
Yeah, so if I will put ourselves from the technology discussion a little bit more towards something else. I mean, we talk a lot about CDMs, GCM verification. So we have a question from potential investors, right, from Pavilion Capital. So the question is directed to Professor Sule about the Gundi Fuel CCS project. Yes. So the question is, could you tell me if the joint credit mechanism actually generates verifiable carbon offsets for investors group?
Sorry, I lost your last sentence.
Okay, so the question is, could you? So the question from the audience is, could you tell me if the joint credit mechanisms actually generates verifiable carbon offsets for investor group? So
okay.
From point of view, how is it generated? The MRV, yes. The MRV part.
Okay. Yeah. I don't know how to answer this one, but what we have experienced with the Gundi project is that, again, I already mentioned that CCUS in Indonesia could be a beneficial project, and we could use the existing oil and gas regulation for CO2 AOR or CO2 EGR, yeah. And then the CO2 that are stored in the reservoir could be offered to the other, to the international communities. And then last year, we received an interest from the Japan government. They said that, okay, this story is quite attractive, but what they have to do is to make a verification whether our findings is logic or could be trusted. So that's why in the time frame of June 2020 until February 2021, two elected companies are doing this verification. Yeah, once the report from them could satisfy METI or the Japanese government, so the JCM could be granted to Kudi project. So this is the story actually, and this model for us is very comfortable, yeah, because it is a win-win solution. Yeah, of course, part of the CO2 that will be injected will be asked to Japanese government, but it's still negotiable. So the first stage to do by all of us is to convince that the findings from us is true, and then we have to develop also the MRV, measurement, reporting, and verification methodology for Gundi project. Yeah, this is.
Thank you, Professor.
Thank you.
In the interest of time, I just pick a couple of questions. There are quite a number of questions, very interesting questions from the audience. So just before I ask the next question, I just want to make a statement that we will answer all the questions. If your question don't get answered on this platform, we will answer offline, and then we will share the answers with the host. So don't worry if your questions are not picked up. Okay, so this is a question to Prof. Rabzwan. We hear a lot about CO2 sequestrations in Malaysia. So the question from the audience is, what are the reasons for considering CO2 sequestration instead of CO2 EOR in Malaysia?
All right. Okay, thank you, Dr. Victor. So, so the question is, why CO2 sequestration instead of CO2 EOR?
Yes.
Yes. All right. Okay. Well, why? Actually, why? Because in terms of capacity, to store, is the best is to store for the CO2 sequestration. I mean, CO2 sequestration in the saline aquifer. That's the best, because in terms of quantity, I mean the volume we can store. But in a way, the good for the C2ER, actually we can get beside we store the CO2, we can get the oil to recover. So that means we can get the money from the C2ER. But for the CO2 sequestration, then the important is because the volume of CO2 we can inject or we can store in that air formation. Okay. All right. I think I like to, talk about the question you asked just now about that Singapore, because Singapore doesn't have that any sedimentary basin. So I think I agree with Dr. Ganesh and Dr. Adam. Win-win situation is very, very important. Right. So, for example, for Singapore need to export, for example, in Malaysia. So they can export the CO2, but the most important, the price, because it's quite far from the field to be applied for the CO2. That is the most important. If the price is very, very low, so that means the CO2 can be viable. Because I have one experience, because I have collaboration one of the oil field in Sumatra, actually, in Riau. Because during the screening, the first choice is CO2 but since it's quite far from the source, it's become not economic. So maybe they change the option for the surfactant EOR or chemical EOR instead of CO2 EOR. Okay, so that means if the cost of the CO2 very is cheap, so that will be the best option for EOR. Okay, thank you.
Thank you, Prof. Robson. So in the interest of time, there are other questions, which I think one of the questions is really interesting, looking at the LCA analysis. The question is really whether we have done any LCA analysis on CO2 life cycle itself. When the liquefaction and transportation of CO2 all entails carbon emissions. So this is the last question is really directed at Ganesh. So we have a question about how to make the transportation, the logistics chain of CO2 transport and sequestration greener? That's actually from one of my colleagues from ESI. And then the other question from, the audience didn't identify his affiliation, but the question is, that's where the LCA question come from, what is, have you looked at that? So, what is your response to that? Whether, from a whole life cycle point of view, about the benefit, total benefit of CO2 sequestrations. You're muted.
Adam, you want to answer?
Short answer, please. We're running out of time.
Actually, Victor, knowing your background, you could answer this as well. There have been studies done by national labs and academics sort of generically, and we have pretty strong LCA capabilities within ExxonMobil as well. It's a fair question. If you don't look at it, you think, gee, does this make sense? And the answer is actually, CO2 emissions for the whole process are very, very small compared to the amount of CO2 sequestered. So from an LCA perspective, it makes a lot of sense. I will say that it's certainly worthwhile to do the detailed analysis in the Southeast Asian context for a specific project. And it's likely as part of a techno-economic analysis, it will be done.
Thank you, Adam. Oh, yeah. So the question is coming from NTU. Just for the audience who doesn't know the term, LCA refers to life cycle assessment or analysis, depending on how you look at it. So I think that's all the questions that we can take for today. So can I just invite Ganesh just to say a few words about the discussions and also maybe the project that we're doing.
Okay, yeah. First of all, thank you for hosting this event. I think events like this will help us sort of understand each other, and then we can move the needle little by little so that we reach the end goal faster. Thank you for taking the initiative. I learned a lot of things listening to the presentation. So every time I listen, obviously I learn a little bit more. So today is no exception to that. I think the big takeaway from most of us is essentially CCS is recognized as a required technology globally. And I think for ASEAN also, it will be one of those technologies. The moment you start thinking about decarbonization and going to the somewhat detailed plans, then it will become obvious that in some cases CCS is required. I think the other thing that we learned here is, like, in terms of technology, in terms of, let me start with policy. So you need a clear policy to start with this. That's the driver. So we are all assuming that as the countries think about decarbonization, so this policy will become more clearer. And then, so assuming that there is a policy, I think the clearly roadmap is we'll start with somewhat easier CO2 projects where CO2 is readily available in a refinery or a chemical plant or something. And then either that could be used for EOR or that could be used for saline storage, obviously depends on the project. But also it's good to, it's encouraging to see that actually regions started thinking about it. I think Prof. Sule gave it a Gundi example, so that's a good starting point. And then Malaysia is thinking about it, and we know from the publications other countries are thinking about it. So we started the journey, so it's so that's an encouraging sign. The other thing here is, I think as the technology is maturing, especially this hydrogen and BECCS and few other things, so we'll see the role of CCS expanding to the what we are currently thinking. So that will actually also accelerate the development worldwide as well as in this part of the world. So I think one thing that I see here is the collaboration is the key. So because I mean, each country can do its own projects, that's fine. But I think what other part of the world is learning here is hubs are the ones which are key. So like, for example, Europe, obviously some countries have this storage capacity, but what they're thinking about is, why don't we collect all these things and develop large scale hubs? Because these hubs offer the economy of the scale. And then, but in order to do that, you need a good collaboration. I think with that, we can accelerate the CCS in this part of the world too.
Right.
Thank you.
Yeah, thank you, Ganesh. So with that, thank you, everybody. Thank you, our panelists. Thank you very much for your time, for your presentation. It's really interesting. Please do us a favor to look through the questions. They are on the virtual platform. As we promised to the audience, we didn't manage to pick all the questions. So let's look through the questions. If they're directed to you, please provide your answers. And of course, for all panelists, even if the questions are not specifically directed to you, please feel free to provide your answer. And then I believe the answers will be published on the virtual platform or somewhere shared with the registered participants. So once and for all, thank you very much, gentlemen. Thank you for your time.